Welcome to section 5.4, in which we'll talk about consumer and producer surpluses. That's going to be our first real-life applications of our techniques and our tools. All right, 5.4.1, let's talk about the demand and the supply functions. So in this section, we'll be considering the market for one specific product. We're assuming that this product sells at the same price for all consumers. So we're trying to see what the price should be, what that price means, and all of this. All right, so first definition 5.4.1, the demand and supply function. The demand function d of x is the price at which the consumers would be willing to buy x unit of our products. All right, so the x that you plug into the function, that's the number of units you're trying to sell, and what comes out is the price in dollars, in millions of dollars, in thousands of dollars, depending on how the problem's set up. So the supply function, S of x, is the price at which the producers would be willing to sell x units. All right, example 5.4.1. Assume that a demand function for a new phone by Mariago is d of x is 1,000 over square root of x dollars. Right, so here's the sketch. I want to evaluate d of 16 and explain what it means. So let's see, d of 16 is 1,000. Sorry, can't really see. Yep, 1,000 over square root of 16. That's 1,000 over 4. That's $250. All right, so that means that at the price of $250, Mariago would sell 16. It's a new phone and they're really just units. So yeah, 16 cell phones. All right, so let's put it on the graph. 250, that's $2, 16. So this is 16, 250. All right, part B. Assume that Mariago plans to sell them at $200. How many units would it be able to sell? So now the price is $200. The price is what comes out, and so here on this graph, the price of 200 would give you the y value, and you're trying to figure out where this is. So 200 would be d of x. So $200 is 1,000 over square root of x. That means square root of x is $1,000 over $200. That's 5. And so x is 5 squared, which is 25. So that question mark we now know is actually 25. All right, so if Mariago sets the phone price at 200 instead of 250, it would actually sell more phones, of course, because if you lower the price, you increase the number of people willing to buy it. So you would actually sell 25 phones. All right, so this is going to be important later on. So let me just run through it. We'll do it again with this exact example later, but I just want you to think about it this way. Assume that the Mariago company decides to sell their phones at $200. It would sell 25 phones, but the 16 people that we found in A were actually willing to buy it for more. They were willing to buy it for $250, and some of them were willing to buy it for even more than that. So the 16 people from A that were willing to spend at least $250 for the phone would still end up paying only $200. We're assuming one set price for everybody. They would therefore be saving at least $50 when buying their phones at $200 instead of paying what they were willing to. All right, so the consumer surplus will actually measure how much money are saved by all the consumer in this way at a set price. All right, so once you set a price for your phones, once Mariago sets a price for their phone, they're selling it to some consumer much lower than the consumers were willing to pay. So they're consumers are actually saving money, and we want to measure how much of money the consumers are saving. All right. Definition 5.4.2, we're going to talk about the equilibrium point. Assume that the market for one specific product has a demand function d of x and a supply function s of x. Then the equilibrium point, x0, p0, is x0, p0, where p0, that's the price. It's the price that corresponds to selling x0 unit to the consumer, and it's the price at which the producer would also be willing um, to sell x0 unit. All right, so the equilibrium point gives the price P0 at which the consumers and the producers agree on the number x0 of units to sell and buy. So it's the price at which a maximum number of units would change hands because they actually agree. All right, so let's try to solve for an equilibrium point. Assume that the demand function and the supply function for a new phone by Mariago are as follows. So again, we have our demand function from the last example, and now we have a supply function on top of it. Find the equilibrium point for this market. So we want D and S to agree. So we want D of X to be equal to S of X. All right, so let's solve for X first. Let me send root of X to the right. So I'm going to get root of X times root of X. That's just 40X. So if I solve for X, I'm going to get 1,000 divided by 40. So that will be 25. Right? So x0 is going to be 25 in my equilibrium. And then I need to find P0. So to find P0, since it's the intersection point of the two curves, you could use either. If I use x of 25, I'm going to get 40 root of 25. I'm going to get 40 times 5. I'm going to get 200. You could use d of 25 as well. All right, so the equilibrium point is 25, 200. And that means that at a price of $200, the producers and the consumers would be willing to buy, actually let's put producers first, sell, buy 25 units, 25 phones. All right, let's put a few things down. I mean, this is in some sense common sense, but let's go through it. If I have a demand and a supply function for a market, the demand curve is, well, let's look here. If I wanted to buy 16 units, I would set a price at 250. If I want to increase the number of units that I sell, I'm going to need to decrease the price. And so that curve is always decreasing. Now the supply function is the opposite. If I want to sell 10 units, then there's going to be a price. Let's pretend like it's $100. If I want to increase the number of units that producers are willing to sell, I need to increase the amount of money they receive per unit. And so I'm going to have to increase the function. I'm going to have to increase the price. So this supply curve is increasing. All right, so I have one curve that's decreasing and one curve that's increasing. And so they will cross only at one y value. So let me draw it without all the noise here. So I'm gonna have one decreasing demand function, one increasing supply function, and they're gonna meet at a single price. Each market has a unique equilibrium point or none at all. So at most one equilibrium point. All right, in the next section, we'll start computing consumer and producer surplus. We'll start defining it and we'll study it a bit.